All right, 311, we are talking about greatest common factors. We are gearing up to start talking about factoring quadratic formulas, and this is for our quadratic formulas, quadratic functions. We are gearing up to do that today. So first one, write the numerator and denominator of each fraction in prime factored form, such as 3 times 3 times 7 times 5. I'm really terrible at reading today, apparently. Then state the greatest common factor of the numerator and denominator. Divide off the greatest common factor to simplify each fraction. Okay, so it gets kind of messy, but bear with me. I think you'll understand it pretty well. So in order to factor these, I'm so slow at these. I just go, okay, it's an even number, so I'm going to divide by 2. It's an even number again, I'm going to divide by 2. Then I go, okay, well, it's not even, so I'm going to divide by this. Divide by this, all the way down to like the bare bones. So I'm going to do that for the top and bottom. So for the top one, I have 2 times 2 times 3 times 5 times 7 times 11. And that was just like going really slow through it, if you want to see my actual work instead of hearing me talk about it. So I'll do the first one, 4,620. Okay, it's even, so I'm going to divide by 2. Okay, still even again, so I'm going to divide by 2 again. Okay, now I see a 5 there. Okay, so I know it's divisible by 5, so I'm going to, divide by 5. Okay, then 231. All right, I know it's not even, so it can't be divisible by 2. So let's see if it's divisible by 3. Yes, it is, because I have a whole number. So divisible by 3. Then 77. I know that's pretty easy. It's a 7 and an 11. Now I'm left with 1. So I'm going to write 2 times 2 times 3 times 5 times 7 times 11. And I'll do the same exact thing for 8,160. I'll just play with the numbers exactly like I just did. Then I'm going to cross out the things that they have in common. There's a 2 on the top, a 2 on the bottom, 2 on the top, 2 on the bottom, 3 on the top, 3 on the bottom, 5 on the top, 5 on the bottom. So I'm going to be left with, when I reduce, 77 over 136. 7 times 7, 77. 2 times 2 times 2 times 17 is 136. What is my GCF? Well, my GCF is what I crossed out on the top and the bottom. So the 2 times 2 times 3 times 5. My greatest common factor is 60. I could reduce the top and the bottom by 60 all at once to get it in the lowest, simplest fraction. Okay, same thing for part B, except we're not dealing with numbers, we're dealing with exponents. So it's x to the 5th, y to the 7th, divided by x squared, y to the 10th. So I'm going to list out 5 x's, 7 y's, 2 x's, 10 y's. Then I'm going to cross out the things that they have in common. There's 2 x's on the top, 2 x's on the bottom. Those cancel out. And then I can cancel out all 7 y's on the top with 7 y's on the bottom. And I will be left with x cubed, y cubed. That's it simplified in reduced to simplest form. So my GCF, remember, is everything that I have crossed out. What I can cancel on the top and cancel on the bottom. It's the thing that they have in common. So I canceled out 2 x's, so x squared, and 7 y's, so y to the 7th. All right, we're going to skip number 2, but if you'd like to look through it, you totally can, but I'm going to skip it for now, and we're going to move on to number 3. If you want to go back, obviously you can read all of the notes. I just want to get through the video as quickly as I can so that you have time to work. So identify the GCF of the terms in each expression. So again, I'm finding what they have in common, like the biggest thing that they have in common. So first, they have numbers. I'm going to look at the numbers first. What numbers can I factor out between a 16 and a 100? And I just kind of use guess and check for these. I'm not going to walk you through my guess and check. If you need me to, jump on Zoom and I can like walk you through how I factor these out. But it's 4. 4 divided by 16. What's left is 4. 100 divided by 4, what's left is 25. Okay, so I'm factoring out a 4. Then I have y to the 4th, x to the 5th, y to the 2nd. What variables do they have in common? What do they both have? Okay, so they both have a 4, and then they both have a y squared. Okay, this y, in this little second part, it's a y squared. Over here, it's y to the 4th. Obviously, I can only cancel out y squared. Can't cancel out any x's because the first part doesn't have any x's in it. So then I'm going to rewrite what's left. Okay, so my GCF is this guy right here. And then I just want to simplify it, just going like one step further. So what's left after I take out 4y squared? What's going to be left is 4y squared and 25x to the 5th. I just divided out that greatest common factor. All right, moving on to the next one. Again, I'm going to look at just the numbers. I have a 51, a 34, and a 68. What number do they have in common? Again, play around with guess and check. I'm telling you it's 17. And then what variable do they have in common? First one has a y and a z. Second one has a y and a z and a w. Last one has a w and a z. So the only variable that they have in common is a z. I can take a z out of everything I see here. And then in parentheses, I'm going to write what's left. I have a 3y left after I divide 17z. And then I have a 2yw and a 4w. If you don't believe me, you could always, or if you wanted to check your work, you could always redistribute this to make sure that you have this as your final answer. So like working backwards, see if you get the answer again. Okay, and then the last one here, a 6x, a 4x squared, an 8x cubed, 16x to the 4th, a 32x to the 5th. Okay, I'm going to look at the numbers. What is the smallest number I could take out for all of them? It's a 2. And then what's the lowest variable I could take out? And it's just an x. Okay, I'm going to factor out my GCF. My GCF is 2x, so don't get that confused. GCF is 2x, and what's going to be left? All of that, I'm not going to read it to you. But that's all that's left. These are your greatest common factors. It's what you can factor out. The biggest thing that they have in common that you can factor out, that you can reduce it by. All right, and some more notes if you want to read through that, go ahead. Otherwise, let's take a look at number 4. It's pretty much the same thing that we've done. This time, the directions actually say to factor out the GCF, which is what we just did in the other one. I just made everyone go a step further than we needed to. So again, I'm going to look at the number. I can factor out a 15. And then I'm going to look at the variable. What variable can I take out? I have an x squared and then an x and a y. I can take out an x. That's the biggest thing that I can take out from both of them. And I'll be left with a 2x and a 5y. I divided both of those terms by 15x. B, again, biggest number between 14, 28, and 7. Biggest number is 7. Then I have an x, a w, and a z, a w and a z cubed, a w and a z. Well, they all have a w in them, so I can take out a w. They also all have at least one z that I can take out. Only the first term has an x, so I can't take out an x from them. And I can't take anything bigger than a z because 14 has a z and 7 has a z. So then I'm going to write what's left after I divide all of that out. Hopefully you're able to see how I'm dividing that out. If not, let me know and I will break it down even further for you so you understand. If you're not understanding how I took this out, you will run into a little bit of trouble in the next couple of sections because it's all on factoring quadratic functions, equations, dealing with all those quadratics. Okay, part C. Biggest number I can factor out is a 4. And then I actually can't factor out any variables because this 24 has no variables attached to it. So they have no variables in common. So I'm just going to reduce everything by 4 inside of the parentheses. Okay. Number 5. The GCF can be used to rewrite a side of a formula so that a variable appears only once, which allows it to be isolated. Simple interest is calculated with the formula I equals PRT, where P is the initial amount invested, R is your interest rate, and T is the period of time. Hopefully you've seen that before and you kind of know, you kind of understand what's going on there. The final value A of an investment, or A is the investment like with all of the interest included in it. So A is given by P plus I. Substituting for I, we get a new formula for the final value of the investment. So A equals the initial amount plus the initial amount times the rate times time. Okay, we only want the P to appear once so that we can isolate it. So we're going to need to factor the right side of the formula so that P only appears one time. So I'm going to rewrite it and I'm going to factor out P on the right hand side. Okay, so like this. What do they have in common? They have a P in common. And when I pull out a P, what's going to be left? Well, P divided by P is 1. P RT divided by P is just RT. So, I'm a little frozen. A equals P times 1 plus rate times time. Okay? I know you've probably seen that before because it's definitely talked about in Math 1. Okay. And then I'm taking it a step further for the next one, and I solved it for P. So, how much should you invest to have $50,000 after 10 years at 4% interest? Use R in decimal form. So, I'm going to use the formula that I solved for up top, where, oh, no, I didn't. So ignore my dividing by 1 plus RT up at the top. Ignore this. Pretend that never happened. Okay, so P. How much should we invest? I don't know. So my initial amount, we don't know. P is a question mark. Time is 10 years. Rate is 4%, so 0.04. Our total amount at the very end, we want to be $50,000. Okay, so this P I actually turned into an X because writing a question mark, some of you would think is silly. So from here, I'm going to just solve for X. So I'm going to divide both sides by 1 plus 0.04 times 10. I'm going to divide both sides by that. And when I do that, I can plug in all of it at once into my calculator. 50,000 divided by 1 plus 0.04 times 10. And I get $35,714.29 if I want to have $50,000 in 10 years. All right. The last part is factor by grouping. I don't actually remember remember learning factoring by grouping when I was in high school. So it took me a little while to understand. I color coded a lot. So hopefully you kind of are able to follow along if you don't remember how to factor by grouping. Some students think that it's very easy, very straightforward, and they love it. Others are a little confused. So we have x squared plus 5x plus 9x plus 45. Factoring by grouping is we're going to take this expression and we're going to divide it up into two groups and factor each little group. So this x squared plus 5x, can I factor out a GCF? Yes, I can. And then in the second group, 9x plus 45, can I factor something out? Yes, I can. But if I was looking at the whole thing as a whole, if I was looking at it x squared plus 5x plus 9x plus 45, could I factor something out? No, I couldn't. They have nothing in common that would factor out. So that's why I have to split it up into two separate groups, the yellow group and the green group. So from the yellow group, I can factor out an x. So when I take out an x, I pull it out in front, I'm left with x plus 5. And then in the green group, I'm able to factor out a 9. They both have a 9 in common. So what's going to be left after I factor out a 9 is going to be x plus 5. Now, from here, it's kind of a jump. So bear with me. We have from the yellow group and from the green group, we have an x plus 5. Okay, so I'm actually going to factor that out. So I'm like double factoring here. I'm going to factor that out. I'm going to bring that out into the front. Once I do that, what's going to be left? X plus 9. That's what's left. And that's my final answer. X plus 5, x plus 9. Okay, let's try another one. We have xy plus 11x plus 10y plus 110. Again, I can't factor anything out as a whole, but I can group it into two separate parts to factor and then factor again. Okay, so we split it up into two different groups. I can factor out an x from xy plus 11x, and I'll have x, and then what's left, y plus 11. Then I can factor out a 10, and what's going to be left, y plus 11. Now, they both have a y plus 11. So I'm going to take that out. I'm going to factor that out. And once I factor that out, what's going to be left? An x and a plus 10. Okay? If you need a little bit more help on that, let me know. I can certainly break it down a little bit further for you if you're still a little bit confused. Otherwise, go ahead and start on the homework.